So what I'm going to do now is I'm going to walk you through what would happen in the lecture portion of our class and kind of describe to you what would happen in the lab portion. I don't have any samples of the mineral, so like I said, we're going to focus mainly on what would happen in the lecture. So one of our first lectures was over sheet silicates, and what they are is they're a group of the silicates, and they kind of align themselves in sheets, so they layer upon themselves. So this is what their structure looks like. All these little triangles with the 3 points inside of them are supposed to look like this. It's a tetrahedra or a triangular pyramid. Okay, and that's what basically in the middle of each of these is a silicon molecule, and then on each of the points is an oxygen. So you have all these kind of stacked together, and they form these little hexagons. Again, going back to the symmetry, you can obviously see the six-fold rotational symmetry. You can draw some mirrors in there, stuff like that. And then in the middle of those, there's usually an OH. There can be other things in there, but that's what we kind of talked about. So under the sheet silicates, the next group down, you have phyllosilicates. Obviously there's other groups, but we're going to worry about the phyllosilicates. And then underneath the phyllosilicates, we're going to worry about the micas. And the reason I chose them is because they're easily recognizable, and they really illustrate how sheet silicates work really well. So micas are going to have one prominent cleavage. So I have a stack of post-it notes, which is going to kind of help illustrate this. Kind of imagine that this isn't so square, like it was just random, but then your top layer is always flat. It doesn't matter how I cut these sides, this top layer is always going to have really good cleavage. It's really soft, obviously this is soft as well, and it has a low specific gravity, so it's not very dense. So what happens with sheet silicates is you can actually put your fingernail down and peel off a layer, which is why post-it notes work really well. And you can just keep kind of doing that. So I like the micas because they show that very well. So then what we talked about was this ternary diagram right here, which represents the whole solid solution that these micas come from. So on each end, there are, there's pure muscovite down here, there's pure margarite up here, and pure paragonite over here. And then stuff that would be in the middle would be a mixture of these. And how you figure it out is if it's all the way in the corner, it's 100%, and if it's on the opposite side, so it's the side here rather than the point, it's 0% paragonite. Same thing with the muscovite, 100% here, 0% here, 100% here, 0% here, and then as you work up, you move towards your other areas. So if you put something directly in the middle, it's actually going to be 33% of each. Now why there's these red areas right here are where the solid solution can actually exist, or where a mineral can form. So you can have a mineral right here, you can have a mineral here, but you can't have this right here. It doesn't exist. So I also put the chemical formulas for the three of them down here. And some of you will know that I called it as silica, so it should have SiO2, but if you look at the formula, there's really no SiO2, or else it doesn't really show it very well. So I'm going to actually show you what's happening here. So what you've got is you have an Al2 here, and an Al2 here, and you have an O10 here. So what this is actually forming is Al2O3, and there are two of them, again because they're Al2s. So you only have 4 of these oxygen left. So then you have SiO2, and you have 2 of those, so those charges balance out. Then you have this K right here, and you have the OH group, which is going to cancel that out as well. Okay? So in the lab, what we would have done is we would have taken, or what we did do, is we looked at minerals, and we said, okay, well, I have this mineral, and it's showing all these signs of a mica. It has one prominent plane of cleavage. It's really soft, it has a low specific gravity, and you kind of work your way down, and muscovite was actually one of the ones that we looked at in the lab. When I edit this video, I'll throw a picture of it up so you guys can see what it looks like. But unfortunately, I don't have any to play around with, so I can't show you, other than on my post-it notes, what it would look like. So what I'm going to do now is I'm going to erase this, and then I'm going to tell you a little bit about what you can expect if you were to major in earth science. Maybe some of the classes you would take up at Penn State, and then we'll move on from there. Okay, so these are going to be some of the courses that you can expect to see if you're going to get an earth sciences major. some of them are courses I've taken, some of them are courses that you'll see next semester with my examples right here. Obviously, Earth Materials, GSci 201, I just took this semester. Next semester they're offering Hydrology and Seismology. They're both 400 level classes. I'm not actually taking them, but I read their description and I mean they seem pretty straightforward. Hydrology, you're just going to be talking about the water cycle and how it kind of affects the Earth. You know, you have your atmosphere, you have the inside of the Earth, obviously you have your biosphere and your hydrosphere, and they all kind of interact. And you know, the hydrology is really going to be used in all these. Water is really important. It affects everything about the Earth. Seismology, on the other hand, you're going to be dealing with mainly earthquakes, volcanic eruptions, stuff like that. You're also going to be taking a lot of Earth classes, hopefully. So some of them you can take are natural disasters, where you're just going to be talking about natural disasters that can happen, how they affect humanity and some of the consequences they have, as well as Earth 400, or as it's also known, Earth Science Seminar, which I took, where you talk about how the Earth forms, and then you kind of move into just how it functions, I guess. It's a pretty interesting class. It's a lot of work, much like GSci 201 was, but it was definitely worth it. You're also going to be taking a lot of science classes. You have to take Chemistry 110 and 112, which are both the lectures, and then 111 and 113, which are the labs. You have to take physics. I think you have to take 2 courses in physics. You have to take a bio class, which I just got done taking. You're obviously going to have to take some math classes. Statistics is in there too. I'm going to be taking that next semester. And then Meteo or meteorology, just because, again, all this kind of works together if you're getting an earth sciences degree. There's other classes you have to take, supporting classes, just like any other major, but these are going to be the bulkier classes. And what they're going to do is they're going to basically show you how the Earth functions as a whole, instead of just focusing on the Earth. Most people think earth sciences and they think, oh, I'm going to be looking at rocks, but the meteorology portion is just as important. The chemistry and the physics and the math are definitely important. In every single one of these science classes, you're going to be using your knowledge of chemistry and physics and math to kind of help you out, and it definitely gives you a distinct advantage over the other students in the class, and just helps you kind of see the bigger picture if you do understand these. So again, when you're thinking of an earth science major, a lot of people think, oh, I'm just going to be taking earth classes or just GSci classes, but again, these classes are just as important to understand, to help you understand, I guess, these classes. So you need to make sure you're paying attention to all that. What I'm going to do now is I'm going to erase this, and we're going to go in the final portion of this video. And I found 2 jobs online that require a geosciences or earth sciences degree, and I'm going to talk to you a little bit about what you would do if you were in those jobs, and what you would expect to want to know, and what this curriculum that Penn State has come up with, how it's going to prepare you for that job.